On. So on Monday and the previous Friday, we talked about the entire pipeline, the data mining pipeline from start to finish, some words of caution and ideas to proceed. What I want to do today, so I'm going to start by sharing the desktop.
You have to start the session first.
Yeah, you have to start.
Okay. So we're going to share the desktop, and I'm going to actually bring up the DataMine website. So in the DataMine website, under the homework, there's a subsection which is the information about the projects. And there's three. So on Wednesday, I mentioned the two data sources, one for everyone at Adams State, which is the this NIH site. And then the other one, I asked the Florida people to make sure that they got the registration to the rda.ucar.edu, the Center for Atmospheric Research website. And presumably everyone in Florida has done that. I can come back and make sure everyone has that if that hasn't already been done. But today, there are now 3 project descriptions. There's 2 groups at Adams, and there's 1 group at Embry-Riddle, and then there's going to be individual variations within those groups as well. So I'm going to start by going over the information for Embry-Riddle. Okay. Part of the reason for that is I'm around a lot and here, and
Sounds good.
so the main thing that we want to do at Embry-Riddle, I thought I had, okay.
Oh, shoot.
This is the basic idea of the project plan, and we can go over this, and I can take questions and so forth. So the first thing you're going to do is you're going to go to the, I forget what CISL stands for, but the Research Data Archive. So we found this on Monday. The people in Florida found this. It's at this link, 15-minute precipitation data from 1971 on to the present. And you're going to obtain the data sets for both Colorado and Florida. So I'll show exactly where this is. So if I guess it doesn't. So let's pull up that website and make sure. This might be repetitive, but we're going to come here, and I remember, because I didn't have the password to log in. I have it in my, well, you'll go to the data access where you come in. And I think everyone's seen this before in Florida, or some of you have, I know. But so we're going to go to the state files, all years in one file per state, the web file listing, and the easiest thing is to go to the complete file list. And notice here you've got different states. You've got Colorado down here, colorado.txt, and Florida at position 9. So if we just take a look, I'll just choose one of these, Colorado. This is what the data is going to start looking like. So what we want to do is you're going to want to, so one of Embry-Riddle's tasks will be to save these 2 files as text files. Okay? And the other thing you're going to want to do at this stage is if we go back to this main stage here, there's a tab for documentation. And the documentation comes in various formats. It doesn't matter what format, the information is what's important here. So you're going to want to look at any version of the documentation. And so I'm going to just take a look here at the PDF, but it doesn't really matter. And the key point here is coming down to where it says element names and definitions. And I'm going to be helping the group with this part of the task because this might involve a little bit of programming, probably in Python, just for reading through. But notice that we have field 001s. It says record position 1 to 3. That's the type of data stored in this record, and the value for all of the data sets, or all of the instances in those positions for this data set will always be 15M, which corresponds to the 15-minute increments that the data is gathered. And so on. So the next sections, fields columns 4 to 11 are your station ID, and it begins with a state code, which is this numeric code. So for Colorado, you will see 05, and for Florida, it will begin 08. And I should have, did I leave the Colorado open as a tab here? Pardon?
No, you did not.
I did not. So let's open up actually, let's just keep that there. And let's open up a tab so we can actually see.
Just copy and paste it. And then go back on that one.
Right, I'm not sure it's going to actually go back.
You can just copy the URL of the PDF. And the URL is.
You have to select
Yeah, the box. URL box.
I'm not used to Internet Explorer. So we're going to take that out and go here again. So the documentation we have, and let's bring up the data again.
I think
Did I?
you went to the wrong one. If you go back one more, you clicked all stations, one file.
Okay.
Okay, so let's just take a look here. There's the first 4 columns we're not going to pay attention to. Notice that on the first record position actually starts on column 5 here. You notice the 15M. And then you notice 05, which corresponds to the state of Colorado. And then you have, until you get to position 11, or actually it's column 15 because the first four you were not paying attention to. And that's going to be your station ID. And going back to the documentation, just so you're aware of what's here and what we're going to have to do. And as I said, I will be building a tool to help you with this task. This is for the Florida group. And it's followed by QP, CP. There might be some instances farther down. I haven't looked at all of the data that have this other element type, which is related to the type of data that was collected. And then it's followed by either HI, standing for hundredths of inches, or HT, which would stand for tenths of inches of precipitation. And then there's a year, month, day. So all of this is encoded in this data here. And then once you get past all of that information, there's now information about actually the times and amounts of the precipitation that happened at that location, at that weather station. Okay, is this making sense? So it's all basically coded. And notice, one thing you want to notice is that, in particular, some rows are longer than others. So how are you going to handle this data? They're at 15-minute increments. So if you notice, the times are like 10:15, 19:15, 1:30, 4 o'clock. But automatically, most of those inputs are zero. Nothing happened. And in terms of the data, they don't record zero. They only record an event if there was actual precipitation in that 15-minute interval, or in that, starting at that time.
So would you separate all the recordings?
So this is one of the, so again, in terms of working with this data, taking this data and putting it into a format that we can use, one thing you might think of is breaking the whole 24-hour cycle into 96 15-minute interval cycles, with almost all of those being zeros, except for the ones where you actually have events. So this is part of the, I mentioned that a lot of the difficulty in working with data mining is at the front end, preparing your data into a form where it can actually be input into an algorithm. This was I saw this precipitation data. I thought this would be interesting, especially for the meteorology students in Florida, to see whether, if you're given an instance now, we'll end up training the data, using some of the data for training and holding out the rest for testing, to see whether it will be possible or not to determine whether an instance comes from Colorado versus Florida, just based on the precipitation record. Does this?
I've got a question.
Yeah.
How are you gonna keep WECA from using the station ID to classify it as Colorado or Florida?
Okay, so that's a good question. So we will not put that in as one of the features,
Okay.
right? you're gonna just put in the features that you'll put in, that it will use. You'll specify to be everything except that. Does that make sense?
Mm-hmm.
So, getting back to the, so we talked about data collection. And here's where I said before we process the data files, first you have to understand what they look like. And in that case, it's what each part of each instance is telling us. So you've got the station, in fact, if you look at that station ID, it's got the first two positions are automatically telling you the state. So actually, I could have skipped part of this at the bottom. So here we went through the documentation. We talked about what features should we use. I suggested, 96 different features corresponding to the different 15-minute time intervals. And then I'm gonna, as soon as I have a chance, I'm gonna work on building a simple Python or MATLAB tool. I don't know if they have MATLAB probably, but I think Python might be easier for stripping out the relevant data that we want from these data sets.
What is the relevant data that we're looking for, I guess? Like,
Well, the relevant data,
what is the question that we're asking?
okay, the question is going to be asking, based upon just the precipitation data, can we identify whether that instance came from a location in Colorado versus a location in Florida?
Okay, so basically we're looking at the data to identify which
Where-
weather
which-
patterns occur. in
Which
what
weather
area.
patterns occur?
Okay.
I'm not sure what this is a data set that I don't know what the results are going to look like. It's fairly sparse, so that we might not get a lot of interesting results from it, but the most important thing is going through the process and understanding the entire process. And we'll find out at the end whether there's interesting conclusions, how accurate we can determine from just the weather patterns, the pattern of the instance, whether a weather station's data comes from Colorado versus from Florida. So at the end, we'll combine the files into a single file with some sort of code which is already built in, but designating the weather pattern coming from Florida or from Colorado, based upon the location. So we might need to go through and actually combine like multiple years worth of weather data for a particular a single weather station in order to get interesting results. So let me see if there's I'll get here. Questions?
Are there any individual parts to this project?
So yes, there will be. So good question.
Your videos
The individual parts. So the first part's going to be working on processing all of this data and putting it into formats.
Oh.
Hello?
Yeah. Yeah. Yes, we're here.
Okay. Any questions so far in Florida? Because what I've talked about mainly pertains to the Florida group at this point.
Yeah, I have a question. Looks like none of them know Python for any natural language processing tool.
Right.
So, manual tool, it looks like it would be terribly hard for them.
No, I'm aware of that. I'm aware of that. I will be building a tool, not this week, but probably next week. I will build a tool that can be used to do some of that processing.
Okay, just to give a template, and maybe they can fill in the Python code.
Right. I will build the Python. I will build the Python code, and I will upload it, and then they can use the Python code to transform the data into something that can be used.
Yeah, that will be the template, and then they can just fill it in. It's easier.
Right, right. And then we can talk about the Python code if students want. But the first thing is we need to transform the data. And so I'm aware that we don't all have the programming experience. So I'll fill in that data.
Yeah. Dr. Eclipse, we have to MATLAB instead of Python.
Pardon?
Could we use MATLAB instead of Python?
We can. I was thinking of Python because I just thought that just looking at the format of the data, it would be easier. Because MATLAB, it's difficult to read in non-numerical data. But I can actually cut it off. I don't have to read in the first, wherever the letters stop, I can start reading in the MATLAB at that position. So I could do it, would be very easy in MATLAB as well. So you would prefer if I build a tool in MATLAB?
That would be preferred, but I know a lot of people who can teach me Python in the meantime, so it won't be too much of an issue.
Okay, I'll just work on writing that tool, the code in MATLAB, and then we'll go over this next week. Is that reasonable?
Yes, sir. Thank you.
Okay. Other questions in Florida before we move to the projects in Alamosa?
Yes, sir. Now, we have a question, just double check. Do we have class on Friday? No?
No class Friday, no class Monday. I'm out
Thank you.
of town.
Yeah.
But I will be available via email. Okay, so moving to the Alamosa groups. So which should I start first, 379 or 479?
379.
470.
Do 379.
379. Oh. Did I accidentally get 479?
Yeah. So just do that one.
You clicked on 379.
Well, the difference is, most of it's the same, so if I accidentally put two 479s up, it won't matter too much, so. What? That'd be funny?
Yeah.
Looks like I have two 479s. Because this is 479. The difference is going to be in the tools that you use for the actual classification. And the formats that we need to put the data into. So for the Alamosa group, we're going to go to a different website. we're gonna go to this website at the NIH. It's the Gene Expression Omnibus, or Geo website. And we're gonna obtain 4 what are called soft files corresponding to these 4 GDS numbers. So we've got, and each one corresponds to a different experiment, but they all use the same microchip array. So we've got GDS 2231 and so on. We can look, for example, and what we'll do is we're going to search in the search box. Wow, what a concept. GDS 1280. So that's going to give us the oculomotor and the spinal cord data sets. And notice here it says the data set soft file. That's the file we want, not the full file. The full file has full annotation and not all of the data. So if we click on that soft file, let's see if it'll do this, or whether I'm restricted.
Select the program. Needs to unzip it.
And then Notepad. Or is it zipped?
Yeah,
It's
.gz
zipped.
is
Where's-
zip?
I don't see zip here.
Try.
Yeah, I don't think
Zip, so
WordPad
it's
would
not
work
gonna
because it's
open
not unzipped yet, right?
It doesn't, it says GZ.
That's got
Right.
zip.
right click happening.
I can try WordPad, but
You have to use
right,
Zipped.
you have to use a,
right, do we have a zip file on?
Go to your
download this.
Download and then right click to see if you can get the tool.
Right,
Go to sources, downloads.
Yeah. He opened it, so it got saved to the 10.
oh, we did? I opened it? I didn't see it.
Computer guys are weird.
I mean, I
Just
don't,
re-download it.
Yeah, download it.
where did I didn't even see that I downloaded it.
well,
so.
we'll just
Where you clicked
Well,
on
do
it.
it
When
again.
it said to open it or save it,
Yeah.
Oh,
click save rather than open this time.
so I went to program file?
No, go back to
So
it.
data set soft file.
Teaching assessments.
You have to re-download it again.
So click on the link again. Yes. Save.
Save.
Oh, save, there we go.
Open folder.
There it is.
There it is, okay.
Oh,
Nope,
No, go back to
now right click it and there should be an option for this.
Open with
Yeah.
other.
other programs.
Still not going.
Is there a WinZip or anything like that?
yeah, there might not be a WinZip on here. That's the problem when you get to a computer you don't use, so.
I think there's one.
Notepad with Notepad?
No, type in file.
No, we don't have WinZip on here.
Type in file. I think the one that Computing Services installs starts with file.
File,
FileZilla.
No,
Zilla.
that's an FTP.
that's FTP.
Oh, that won't do it then.
Alright, I guess it's not on there. I was really thinking that would be.
And GZ, right,
Right click on it again. G's.
yeah, that's not gonna, we looked at that. Open with,
What's this Skype drive?
I don't think there's anything on there that we can open it with.
we can do browse.
Hold it from the file.
Program files,
That's where you are.
Yeah, but he's in the 32 now.
Yeah.
No.
Not
And I don't have the administrative privileges to add things.
Nope.
So much. Well, we can go through, I can talk about what the data looks like. We might be able to find it in another, see, my computer automatically opened, but. So let's maybe back up. Is that in I can't even. Well, what I can do is we can take a look at what you'll see. There's a bunch of information at the top, but then I think if I press on sample subsets here, we'll be able to take a look at what's, that only has partial information. Is that maybe the full table has it? No? I did not realize that it was a zipped file. So I just downloaded it and it opened because I have the tools.
Different operating system.
Well, yeah, but it also has the tools. I already have it. So it opened automatically. I wonder if I can open it here without downloading it. No. You tried open, right?
Yes.
Yeah.
I'm wondering if any of these have any information. That's a gzip file too. I'm just, is there anything else that it would be under?
Oh, there it is.
There it is,
How is it?
file zip.
No.
Did I,
Yeah, it's open. So you see.
there it is.
Continue.
Can you?
So.
And it's yeah. Okay, and where did it save?
Cool.
Download?
Downloads.
So go to,
Yeah.
There we go. And then you want to hit the arrow right next to it, extract.
Right. And probably also on downloads.
If you close that and scroll down a little bit, it's got your username.
Oh, there it is.
And then you go back to that file or that explorer.
So let's take a look. There it is. One of those. We got it. Now we want to do like
add,
WordPad.
Yeah.
Okay. Sorry about that delay, but this is what the data is going to look like. Okay. And there's a bunch of headers at the top. We're gonna pretty much want to strip that out, that's easy to do. Here's going to be the beginning of the data, and a little bit here, where it says so starting here, data set table begin. And we notice we're gonna have a header file at the top, or a label ID reference and our identifiers. All these basic GSM, this is one line, it just wrapped around. So from GSM 74342 to 74341, at the very end, that's a single line. It's just the formatting, you can't see it all because it's like going over here.
Took you like the fonts.
Oh my goodness. So
You could, I mean, what?
I'm just trying to think of how to put that into Excel.
Oh, that's not gonna be difficult, actually.
Okay.
Okay, and we can talk about that, you can just import it. I mean, basically, what you can do as a text file, you could save it, you could strip out all that header information up until where it says ID ref, right? Just get rid of everything above there.
Yeah.
And then the rest of this, notice it's all tab delimited. To get from one column to the next, it's just tabbed. And then to get from one line to the next, it's a return.
Okay.
So that's perfect for importing into Excel. And we can talk about that.
Cool.
So that's not going to be difficult. There's some pieces that are not going to be straightforward.
Okay.
Okay? So we've got these different, you notice here on the second line, it's Sumo 2, those are codes for your different gene types and so forth. Those are what we're interested in. You have here CDC 37, COPB2, and so on. Okay?
So those are the classes that we're trying to get into?
Those are going to be our features, our attributes. But we've got 4 files, so let's talk about this. Let's go back to the plan here. So that's what each of those data set, the soft files look like. Okay? So you're gonna want to use a text editor to basically read and save those 4 files. Everyone with me? Should be pretty straightforward. Okay. So now, as I said, the soft file has a bunch of descriptive headers. That was all the stuff before the data table actually began. And then a tab delimited matrix with row and column names. And microarray probe names. And those actually, not Gene, those are, that was like the Sumo 2. Those are your microarray probe names. Those are going to be your, no wait, the microarray probe names are going to be the rows, and then the sample codes. The samples are your GSM, number. Those are your sample, the codes for your samples, and those are your columns. Okay? The expression values are pretty raw, but I mean, we're going to treat them as raw, but they're actually fairly heavily processed already. The second column is the Sumo 2. Those are your gene symbols. The first column is the microarray probe. That's just the different locations that they probed everything. And there can be more than one probe annotated by the same gene symbol. So this is kind of crucial here. So you might have two different probes, both corresponding to Sumo 2. Okay? Everyone with me?
Are we gonna take the average of those two probes?
Exactly, okay? So our first step will be to transform those files by applying the gene symbol annotations to each probe. We're gonna replace basically, we're not interested in the probes as much as the gene symbol. So that the features are unique. So, and taking the average value, like for each of those for each sample, for that particular gene symbol. And then, and this is also actually fairly easy. You're gonna take the log base 2 of that average value for all your data points. So you're gonna take the average whenever there's overlap from a sample, and then you're gonna take the log base 2 of that average. And for the most part, all of that should be doable within Excel. Does that make sense? And that's gonna be the first step in the process.
What does the log base 2 give us?
Well, it's just basically, as it says here, that's kind of how the data for microarray analysis is just standardly handled. It basically just gives a narrower range of values. Right, if you've got a wide range, now it's putting it into log base 2 so that it's log base, anything would be equivalent, but in log base 2 you're taking exponential range of data into more linear range.
Okay.
So what are we doing with the gene information? What is our question?
So, so we will want to save the data as CSV files. And now here's where the two projects are going to diverge. One of them is going to use Moses over on the supercomputers. We've downloaded it on at least one machine, and it's installed. And I'll be around a lot starting next week to help with all of this. But the other group will be working with Weka, and that didn't get put up here. But basically, in the Weka, you're pretty much ready for that group once you're here, right? Because at this point, if it's in a standard CSV format, it can be imported into Weka. In terms of the Moses group, because you're the 479 group, you've got more processing to do.
Okay.
Okay? Which means what you're going to have to do is,
Stay imported.
and it depends upon the current state of Moses. Last time I looked, it still only dealt with binary data, but I know that there was work being done at the time trying to use continuous data, and I don't know where that is at. For the time being, let's just suppose it's binary data that as the input, in which case we have to turn all of those values into binary data. We're going to do that by taking what's called median normalizing it. What that means is we're going to look for the median value, and if a particular value is below that, we're going to make it a 0, and if it's above that median, it becomes a 1. So you're using the median as the split point. And
So yeah, we're converting it to binary?
we're converting it to binary, right? Now, the one tricky point here for both groups, wait, is that true for the, yeah, it's true, I think, for both groups, is that we're going to have to transpose the data.
So we're gonna have to do
So, because the way it's written,
Yeah, I don't think it'd be that.
I really don't
So-
think it'd be that hard.
it depends on, in Excel, it depends on the size of the
Right.
data that we're
That's-
looking with.
That's what we were talking about.
And so, again, I will be around to help with that process. It's not all that tricky. I can do it in MATLAB or in Python, and we can work through that, just like I mentioned with the other group. And then the last stage is you're gonna, just like with Embry-Riddle, we're gonna label the data, 0 for young samples and 1 for old samples. And in this page, I actually kind of look at what I give you what the classification should look like for each of the 4 types of data that you're looking at. And notice the binarization here depending on the probes. So, I'm gonna leave it there. I know that there's a lot that you'll have, a lot of questions will arise as you start going through all 3 of these projects. But I really believe that this is, by putting everything together, this is where you'll learn how to do data mining. Does that make sense?
Yeah.